All right, today in Algebra 2, we're going to look at the second day of 6.4. We're going to talk about graphing logarithmic functions with transformations. So remember, with exponential functions, the value of k shifts the horizontal asymptote. But with logarithmic functions, the asymptote is vertical, therefore the value of h is going to shift our asymptote. Y equals a times log base b of x minus h, all of that plus k. That's what our basic transformations are going to look like. Remember, if the absolute value of a is greater than 1, this is going to be a vertical stretch. If the absolute value of a is between 0 and 1, this is going to be a vertical compression. X minus h still moves at right h. X plus h still moves at left h units. Plus k still moves at up k units, minus k still moves down k units. Our asymptote is x minus h, so whatever that h is. A negative a is just a reflection. So now let's graph some of these using that. So it says graph the log using transformations of the parents, state the domain, range, intercepts, asymptotes, and end behavior. So we're going to start out with what is our parent function. So our parent is going to be 2 to the y equals x. Make our xy table. Remember, we still pick the y's, -2, -1, 0, 1, and 2. 2 to the -2 power is 1/4, 1/2, 1, 2, and 4. So now, log base 2 of x plus 3, my x's, remember that always comes out opposite, so I'm going to do x minus 3. My y's are all going to stay the same. So -2, -1, 0, 1, and 2. So I'm going to subtract 3 from all of my x's. So 1/4 minus 3 gets me -2 and 3/4. 1/2 minus 3 gets me -2 1/2. 1 minus 3 gets me -2. 2 minus 3, -1. 4 minus 3 is +1. The entire graph shifted to the left 3, right? So this shifts left 3. So my domain shifted left 3. So now my domain is at -3 to infinity. My range is always -infinity to infinity. My intercept, okay, remember that intercepts usually are at 1, 0, but it shifted left 3. So now I see my new intercept is at -2, 0. My asymptote is x equals my h, so -3, because that always comes out of parentheses opposite. So my end behavior, we're going to look at as x approaches -3, what does y do? As x approaches infinity, what does y do? So over here at -3, we're going to draw our asymptote. So now we're going to plot these points. So we see -2, 0 is my new intercept, -1, 1, 1, 2, -2 1/2, -1, -2 3/4, -2. So it just took that log function and shifted it left 3 units. So as x is approaching -3, my y's are getting smaller, -infinity. As my x's are approaching infinity, my y's are also approaching infinity. So that's not going to change, just like we talked about yesterday. If my base is a nice whole number, as my x's get smaller, my y's get smaller. As my x's get bigger, my y's get bigger. Let's look at number 2. H of x equals the natural log of x plus 4. All that this is going to do is shift it up 4 units. So our parent, e to the x, or sorry, e to the y is equal to x. Pick -2, -1, 0, 1, and 2. E to the -2 power is 0.14. E to the -1 is 0.37. E to the 0 is 1. E to the first is 2.72. E squared 7.4. My domain, I don't have anything shifting left or right, so my domain is still 0 to infinity. My range, -infinity to infinity. My intercept, okay, we don't have it on here, but this is shifting it up 4. Sorry. So if it's shifting up 4, my intercept would have been a -4 over here. So I'm going to go ahead and plug -4 into my parent so that we'll get our intercept on our new graph. So if I plug in e to the -4, I get 0.0183. My asymptote is still going to be x equals 0. In behavior, as x approaches 0, y approaches -infinity. As x approaches infinity, y approaches infinity, because my base is still that e. We can go ahead and do our asymptote, x equals 0. So now we're going to do our new xy table. Our x's are going to stay the same. Our y's are just going to get 4 added to them. 0.14, 0.37, 1, 2.72, 7.4, 0.183. So -2 plus 4 gets me 2. -1 plus 4 is 3, 4, 5, 6. The -4 plus 4 gave me the 0. And remember, we did that to get our x-intercept. So our intercept over here is the 0.183, 0. So let's see, 0.14 I'm up at 2, 0.37 at 3, over 1 up at 4, 2.72 up at 5, 7 point something up at 6, 0.183, or 0 right there. So my asymptote, oh, you know that does not cross our asymptote. Got a little crazy on drawing that. So that's what that looks like. Let's look at number 3. H of x equals 5 times the natural log of x. Our only transformation here is a vertical stretch. That's all that's happening here. My domain is still 0 to infinity. My range, -infinity to infinity. My intercept is going to be still 1, 0. Asymptote still x equals 0. In behavior, as x approaches 0, y approaches -infinity. As x approaches infinity, y approaches infinity as well. My parent function is still that e to the y equals x. So the same one that we had up top, -2, -1, 0, 1, and 2. 0.14, 0.37, 1, 2.7, 7.4. So my asymptote here so my new xy table, x's stay the same, my y's get multiplied by 5 because of that 5 out front. So 0.14, 0.37, 1, 2.7, 7.4. -2 times 5, -10. -5, 0, 5, and 10. So 0.14, we're way down here. At 3.7, we're at -5. 1, 0. 2.7, we're up here at 5. Here, 7.4 would be way up there. So we're just stretching this out. We're going to look at one more of these today. So our last one we're going to look at today, y equals -2 log base 2 of x plus 4. So our transformations, we have a reflection, we have a vertical stretch, and up 4. My domain is still 0 to infinity. My range, -infinity to infinity. My intercept, we'll talk about that in a minute. My asymptote, still x equals 0. My in behavior, as x approaches 0, and as x approaches infinity. And we're going to talk about that in a minute. So let's look at our parent. So our parent is 2 to the y equals x. So -2, -1, 0, 1, and 2. So this is 1/4, 1/2, 1, 2, and 4. Go ahead and put our asymptote in over here. So my new one, reflection, vertical shift, and F4, those are all y's. So my x's stay the same. So we're going to do negative 2y plus 4. So all of my x's stay the same. So we're going to multiply all of our y's by negative 2 and then add 4. So negative 2 times negative 2 is 4. 4 plus 4, 8. Negative 2 times negative 1 is 2. 2 plus 4, 6. 0 plus 4 is 4. Negative 2 times 1 is negative 2 plus 4 is 2. 2 times negative 2 is negative 4. Negative 4 plus 4 is 0. So that gets us our x-intercept right there, 4, 0. So 4, 0 is my x-intercept. 2, 2. 1, 4. Half up 6. So this is what my graph is going to look like. Notice because of the reflection, my end behavior is going to be this, just the opposite. So as x is approaching 0, my y's are getting bigger, infinity. As x's are getting bigger, my y's are approaching negative infinity. All right, so that's where we're going to stop at today. So this is graphing logarithms with transformations. Your homework will be over this, graphing logarithms with transformations. So remember, I need to see the XY tables of the parent and the new XY tables.